Welcome back, ladies and gentlemen. So today we're going to finally get to solving exponential and logarithmic equations. Okay, so we're going to learn some really important properties today and see how we can use them in actually solving some problems. Okay, so to start off with, some little practice problems. Log base 4 of 1/16 equals, remember we always make it equal to x. It's the base of your log equals this, the base of your log raised to this power equals that. So 4 to the x equals 1/16. Now to make something reciprocate or flip, it needs to be negative, and then to go from 4 to 16, it's just raised to the second power, so -2. Cool. Okay. Here, 2 raised to the x power equals 16. Well, what raised to 16? Well, 2 raised to what power gives you 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's the fourth power. Finally, here we have -3 raised to the x power equals +3. Well, okay, you can try and figure out anything you want here. You can do a negative, you can do squared, whatever you want. There is no possible way to raise a negative number to a value to get the same value but positive. So this is going to be a no solution. And this is going to be big later on when we start talking about more extraneous solutions. Okay? So, awesome. Alright, what we have here, there are two basic strategies for solving exponential or logarithmic functions, one-to-one properties and inverse properties. Please take a moment and jot these down, and I will explain what they mean in a second. They are going to freak you out a little bit because they're all variables, but I promise they're not bad. A to the x equals a to the y, if and only if x equals y. Two things are equal only if they have the same base, they have the same exponent as well. Okay, so that one's kind of simple. We'll see that one real soon. We can also say log base a of x equals log base a of y, if and only if x equals y. This is another one I like to call duh, because if I have the same log base, then whatever is here has to be the same as well. So we can just make those equal. This one's really, really nice. You guys are going to enjoy that one. The inverse properties, these are a little trickier. A raised to the power of log base ax equals x. If you can take something and raise it to the log with the same base, whatever this number is, that's what it will equal. Okay, I will show you this one in more of an example problem. It'll make a lot more sense. 2, you can also do log base a of a raised to the x. That will equal x as well. So if I have log base a of a, okay, these are going to cancel out. It basically becomes 1, and then whatever the exponent is, that's your answer. So again, these ones kind of tricky. You'll see them in context. They're not bad. These ones are really simple once you get the hang of them. Okay. So here we got a few examples for you guys. Let's get going. 2 raised to the x equals 32 raised to the x minus 4. When you see this, a little bell's got to go off on your head. Okay, you should go ding, ding, ding. I was going to draw a bell, but I'm not a really good drawer. I have 2 to the x. That's cool. Is there a way for me to rewrite 32 so that it has the base of 2? So basically what I'm asking you is this. 2 raised to what power gives you 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32. So I can rewrite this as 2 to the 5th power. But I still have that x minus 4 right there. Well, now we're in really, really good shape because I have the same base, 2 and 2. If I have the same base, all I need to make them equal is make the exponents equal. X equals 5 times x minus 4. And this becomes a very easy problem to solve. I can distribute that 5x minus 20. Okay, I'm going to go ahead and subtract x over. 0 equals 4x minus 20. I'm going to add 20 over. So 4x equals 20. X equals 5. Okay, and we're good to go. Okay, we could check real quick. 2 to the 5th power gives me 32. 32 raised to the 5 minus 4 power is still 32. We're in good shape. This one looks super scary. It's actually quite simple. What I can do here is I have natural log of 3x minus natural log of 27. I'm going to add the natural log of 27 to the other side. because now I have a natural log equals natural log. Sweet. Well, that just means I need those things to be equal. Okay? So 3x equals 27. X equals 9. Okay? And we're good. We're all good. So if I plug that back in, 3 times 9 is 27. Natural log of 27 minus natural log of 27 does indeed equal 0. Okay. Now, this is a little bit of a new step for you guys. E to the x equals 7. Okay, so what we can do when you have an x in your exponent, okay, and you can't make the same base, okay, which is what we always look for first, what we want to do is take the log or the natural log of both sides. Now, since there's an e, I'm going to take the natural log of both sides. All I did was take natural log of both sides. It's kind of like how you add 5 to both sides, you divide by 2 both sides. Well, here's the interesting thing. Natural log of e. I want to show you guys this. It's kind of cool. The reason this is so helpful is that if you take the natural log of e, a equals 1. Well, if I have an exponent, what you can do is bring that exponent out front. So x natural log of e equals natural log of 7. Well, we just said that natural log of e is 1. Gone. X equals natural log 7. Done. I know that seems really complicated, but we're going to be using this step a whole lot whenever you have an x in your exponent, okay, and we can't make the same base. All right. Finally, part D, this is where these properties over here are really going to come into play. All right, this is what we did right here, but I'm actually going to show you an even easier way that I thought just makes it way more sense because it's something that you already know. The base of a regular common log is 10. There's a little 10 written down here, even though it's not there. I'm just going to rewrite this. 10 raised to the negative 1 power equals x. Well, okay, my answer's already there for me. 1 over 10, negative exponent, you flip it. You're all set. Okay? So if you have a log and you want to rewrite it, just rewrite it in exponential form and things are going to work out real nice for you. But we can only do this when you only have 1 log. Notice how up here I had 2. Okay? Alright. On to our back. Okay? So, let's see here. Okay, so we have some strategies for solving exponential logarithmic equations. And if you guys follow these 3 steps, normally you're in really good shape. Step number 1. Make both sides of the equation have the same base. Okay, so that's how we did the first one. We had 2 and 32. We wanted to write with the same base. This one is kind of hard to pull off. If it does, it ends up being the easiest problem. Okay, so good. If that does not work, we take the log or natural log of both sides of the equation. Okay, so if you have an x in your exponent and you can't rewrite so that it has the same base, we take the log or natural log of both sides. And finally, if that doesn't work, we can exponentiate both sides of the equation. These are our 3 steps. If we always follow, we'll be in good shape. So, let's take a look. 4 to the x equals 72. Is there a way I could rewrite 72 so that it has a base 4? Hopefully you're all shaking your head no. 4 times 4 is 16, times 4 is 64. It's not going to give me 72. So what I'm going to do here is this. I'm going to either take the log or natural log of both sides. Typically you look at the base of your exponent, okay, and if it's a 10 or an e, if it's 10 you definitely pick this one, if it's e you definitely pick this one. Since it's a 4, I don't really care. So I'm going to pick the natural log because why not? And I'm taking the natural log of both sides. Now the exponent gets pulled out front. X natural log 4 equals natural log 72. Now, I want to get x by itself. I'm going to divide both sides by natural log 4. So x equals natural log 72 divided by natural log 4. And that's it, okay? Because I can literally come over here and go natural log 72 divided by natural log 4. So 3.08 would be my answer. I will tell you, we'll let you know on a test or quiz if we want you to leave it like this or like that. Okay? Cool. Over here, 3 times 2 to the x equals 42. Divide by 3. You have to get the 2 raised to the x by itself first. So 2 to the x equals 14. Sweet. I can't rewrite 14 as a base of 2, so take the log or natural log of both sides. This time I'll take the log of both sides. So log 2 to the x equals log 14. Pull the x out front. Okay, and divide log 14 divided by log 2. Please be careful here. This will never, 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 never be log 7. Okay? So I'm taking this, log 14, make sure you close it, divided by log 2, and we get 3.81. Cool. Alright. Last two, subtract 5 over. Subtract 5, e to the x equals 55. Now, notice how my base is an e here. Since it's an e, I definitely want to take the natural log of both sides. So, the x comes out front. Natural log of e equals natural log of 55. Now, why did I want to take the natural log of e so bad? Because the natural log of e is wonderful in the fact that natural log of e is 1. Okay? So this kind of just cancels out. X equals natural log of 55, which, if you want the decimal approximation of it, 4.01. Okay, very good. All right, finally, here for part D, I want to get this junk by itself, so I have to add the 4 over. So I have 2, 3 raised to 2x minus 5 equals 15. Divide by 2. 3, 2x minus 5 equals, we'll call that 7.5. Okay, so now I want to get the exponent by itself. I can't rewrite 7.5 as the base of 3. I'm going to take the natural log of both sides. So think about it, my exponent is 2x minus 5. That goes out front. Okay. So now I want to get this by itself. I'm going to divide both sides by natural log of 3. So 2x minus 5 equals natural log 7.5 divided by natural log 3. Okay. Here, this is one thing. Okay. So I'm going to add 5 to it. Plus 5. And then I'm going to divide everything by 2. So please look how absolutely, positively ugly this looks. Bam. So if you really want to put this in a calculator, you have to be careful. I would go parentheses, natural log 7.5, close, divided by natural log 3. Okay. I get that. I'm going to add 5 to it, so plus 5. Take that and divide all of it by 2. So it's approximately 3.42. Okay. So, a lot there, but we're going to get lots of practice with this because, I mean, you literally just do the same thing every time. And again, once you get the hang of it, it's actually a really simple way to solve. So, hope this makes sense. If you have any questions, please feel free to ask for help. And as always, keep up the good work and good luck. We're all counting on you.